Hi, my name is Steve Tracy, and today I'm going to tell you about how to determine simple molecules in a water sample. So the instruments used to determine this are infrared spectrometers and a nuclear magnetic resonance. And those can be abbreviated IR and NMR. So both of these instruments measure the amount of electromagnetic radiation in a sample. How the IR works is that the absorption of a photon in the infrared region leads to an increase in energy in molecular vibration. The way that an NMR works is that the absorption of a photon in the radio frequency leads to excitation of a hydrogen nucleus. When the molecule is more complex, the more vibrations it will have, leading to more peaks in the graph, according to Experiment 3 in the Mount Union Lab Manual. So we were given 15 different molecules and their structures. As seen here are a couple. Here are methanol, ethanol, T-butanol, 1,4-dichlorobutane, and 2-chloropropane. So from this, we had to determine certain functional groups that were present. And we had to put them into a graph such as this, or a table such as this. So for example, up here you can see methanol. This is the structure, CH3OH. So the way to determine the functional groups is that you have to look at the CH here in the orange and the OH. So there are two functional groups present. And we can put them in the table up here. And we do that for all of these so you can see how they are either similar or different based on their functional groups. The next step is to determine the number of peaks. And this is done by looking at the different hydrogen bonds that there are. So there are two different hydrogen bonds. There is a CH here in the orange and an OH here in the yellow. So that means there are two peaks present. Next we have to determine the ratio. And we can determine this by the number of different hydrogen bonds there are. So we know that there's a CH bond and an OH bond. And there are 3 CH bonds to 1 OH bond. So the ratio would be 3:1. So then these are all placed in the table and we can use them for future reference. The unknown that I was given was 4060. And the IR spectrum is shown here, and the NMR spectrum is shown here. And we are given that certain functional groups have a certain range of absorption, as seen here. So the first step of determining the unknown, we have to go back to the IR spectrum and look at where the peaks are. The peaks are at 3,368.59 inverse centimeters and 2,973.46 inverse centimeters. So then if we come back to the graph here, or the table here, we can determine that there is an OH functional group and a CH single bond group. Next we have to determine the amount of peaks, and simply you look at this and you can tell that there are two peaks, one right there, one right there. And this also tells us the ratio by telling us at the top of it 9:1. So if we look at the functional groups of each of these, we can determine that the unknown by the functional groups is either methanol, ethanol, T-butanol, or 2-propanol. Once we narrow that down, we know that we have to have two peaks. So there's two peaks in either methanol or T-butanol. And we know that the ratio is 9:1, so the unknown is going to be T-butanol. So some practical uses for this experiment are that, say there's a certain molecule that has contaminated the water in our city or something, or some other liquid. We can use this to determine what the molecule is and use the certain separation method to extract that molecule. This is according to phys.com. So, in summary, the way to determine what a molecule is in the unknown, you have to first find the functional groups and categorize it. And then from that, from the structure, we can tell the amount of peaks from the different amount of hydrogen bonds present in the molecule. And then using the amount of hydrogen bonds, we can find the ratio by comparing the amounts of different hydrogen bonds. References. Thank you for listening.